Hi, welcome to Brain and Behavior, Psych 157. I'm Dr. Melissa Cook, and I will be your instructor this semester. A little bit about me. I completed my PhD about a dozen years ago at UCLA, and I'm just realizing how old that makes me feel. I also found out today that Macaulay Culkin is 40, so I'm sorry, I'm just reeling a little bit. For about 15 years, I worked as a research scientist in an interdisciplinary lab devoted to the study of human learning in all kinds of contexts, from kindergarteners learning physics in a virtual reality play space to early career scientists learning on the job in laboratories. And I loved that job. But like a lot of science research, our funding went up and down a lot, so I started picking up adjunct teaching as a way to fill in the gaps. And I've never stopped because I love it so much. And this class is my absolute favorite class to teach. I've been pretty obsessed with the material I'm going to share with you since I was a little kid. I actually did my 6th grade science fair project on lateralization, which is the difference between the right and left hemispheres of the brain, and I looked at how they process sounds differently. So, huge nerd, very popular in middle school. But what I am hoping one of the benefits you get out of this class is that a little of my enthusiasm actually translates to you. So, what I want to do today is sell you on the idea that learning about the brain is a worthwhile use of your time this semester. To begin, I'd like to invite you to imagine that you are a brain. So you are about 3 pounds of gelatinous goo, and you're locked inside this bony skull. No light is getting in, very little sound waves are penetrating, so you, as a brain, are really alone in the dark. And all you have to make sense of the world are faint electrical signals that are sort of related to what's going on in the world around you. And from that very limited information, your job is to figure out everything the organism needs to survive. It's a really big job for one organ to do. I haven't scoured the course catalog completely, but I'm kind of doubting that there are many other classes at Mount St. Mary's devoted to one organ of the body. You guys let me know if there's like Gallbladder 101, I might want to take it. So I think this is because the brain is the most important organ of the human body. I know that every professor thinks their subject is the most important, but since you're in my class, just go with me on this. So somehow, your 86 billion neurons and the glial cells that support them are cooperating to generate every aspect of the conscious experience that you're having right now. So hearing the sound of my voice, seeing my face on the screen, feeling the feeling of sitting in your chair, the smell and temperature in the air around you, whatever annoying noise your roommate or family might be making right now, or in my case, the feeling of the soft and comfy sweatpants that I am definitely wearing below where the camera can see. All of that is happening inside 3 pounds of electrified goo between your ears. Hopefully I have at least a few Harry Potter fans in this class. There's a scene at the end of the final book and film that's really insightful from the perspective of a neuroscientist. And what's going on in this scene, mild spoiler alerts for Harry Potter 7, is that Harry is having a sort of vision of a place that might be something like an afterlife. We aren't really sure as audience members at this moment. And as Harry's looking around and seeing this kind of mystical setting, he asks Dumbledore, is this all real? Or is it happening inside my head? And I love Dumbledore's answer to Harry in this scene. He says, of course it's happening inside your head, Harry. Why would that mean it's not real? I love what Dumbledore said here, because the fact is, for each of us, our own mind is all there is. Everything you are ever going to learn and discover in your life is going to happen here, inside your brain. Every emotion you're ever going to have, all of the pain that you're going to experience in your life, the early 2000s Destiny's Child lyrics that you will not be able to delete from your memory files, no matter how hard you try to replace them, they are all happening here in the 3 pounds of electrified organic material between your ears. So Dumbledore has brought us to what I would say is probably the number one core principle of this course. And that is that everything psychological is biological. What that means is that every mental event translates into a neurochemical event. So all of our thoughts and feelings can be described as electricity and chemicals moving in the human brain. All of the big questions humanity faces, if we are to solve them, will be solved inside human minds. Are we gonna figure out how to live more lightly on the planet and preserve the climate for generations to come? If we do, it'll happen here. Are we gonna get it together to create a less racist and more equitable society? If we do, it'll happen here. Every discovery, every invention, from putting human beings on Mars to whatever makeup Rihanna is going to create and sell me next, all of that innovation will come from the work of microscopically small chemicals moving across the membrane of neurons in the human brain. Without your mind, you don't exist, and the world does not exist for you. So studying the mind, I would argue, is fundamental to all human pursuits. And this importance of the brain to the human life is evidenced by the emotional connection that we have to our brains as compared to other body organs. So let's do a little thought experiment. So let's consider the case of an organ transplant. So I'm actually going to bring one of you guys into this discussion. Thank you, Kristen, for being part of this example. I salute you. So let's pretend that I am in dire need of a kidney, and Kristen is generous enough to donate it to me. I mean, she has a very kind face. I think it's plausible. So Kristen donates a kidney to me, and I'm waking up post-op, groggy and confused. Now, I'm a little bit different. I still have Melissa's body, but I have a piece of Kristen inside of me. I have Kristen's kidney. Am I me? I think most people would say yes. Even if the transplant were something like bone marrow that moves throughout the body and has a bigger effect on my personhood, I think most people would still say, yes, after receiving Kristen's generous bone marrow transplant, you are still you, Melissa. Now, Kristen survived in those hypothetical examples, and I'm very sorry, Kristen, but you are going to be killed in the next thought experiment. Thank you for your service. So let's imagine that there's been a tragic accident, and I am in need of a new face. And Kristen's family has made her an organ donor, and I'm going to receive her face as a face transplant. This is a real surgery that has been done in the past couple of years. So now I'm Melissa, but with this very intimate body organ replaced. I'm Melissa with Kristen's face. Am I still me? Most people still agree that yes, that being is me, Melissa. But finally consider, what if, after another tragic accident, really feeling klutzy, I receive Kristen's brain in the first ever human brain transplant? Let's say I survive the operation and I wake up as a creature with Melissa's body and Kristen's brain. Who is that person? Really think about it. If I called on you in class right now, what would you say? Now, I've gotten lots of types of answers to this question when I've posed it before. Some people feel it's pretty cut and dry. The person is Kristen. Kristen's brain, Kristen's being, even though it's in my body. Other people aren't so sure. There's been an argument made that maybe this is kind of a new and hybrid creature, because while it has Kristen's thoughts, memories, and perspective, it also has my embodied experience and is moving through the world as me. And there's a lot to be said for the validity of that concept from a neuroscience perspective. One of the things you're going to learn in this class is that the brain, while it gets most of the attention, is really just a small part of the human nervous system. And our brain is highly informed by other nervous systems that are active in the body. So this new creature that had Kristen's brain but Melissa's body would also have Melissa's somatic nervous system, which might influence how it moves and how it perceives pain. It would have Melissa's autonomic nervous system, which could influence how nervous or anxious this new creature becomes in different situations or how relaxed it feels. And it would have Melissa's enteric nervous system, the system that manages digestion, which can actually affect a person's mood. So a lot of things about Kristen's experience would be changed by having a new body with these new nervous systems cooperating. So remember that the brain isn't the end-all and be-all of the neural experience. Nevertheless, I think most people still fall on the side of feeling that it's in the brain where we have our memories, our history, our passions, our fears, that the self resides. And this is another reason that I think the study of the brain is so important. Your brain creates that sense of self. And we see this, that when brains are damaged in particular ways, or when people ingest particular substances that change the way the brain operates, their sense of self can change or dissolve, as in the case of the oneness some people feel when they take psychedelics. So we've established that everything psychological is biological, that every mental event translates into a neurochemical event in the brain, and that it's our brains which create our sense of self, the narrative that we carry forward through our lives. And it's also fair to say that your brain constructs your world. Now, we all know that the brain is the organ responsible for perceiving the world around us, but most of us have a pretty simplistic notion of how this works. We tend to think that, we see something like this cute kitten, the light rays that are bouncing off the kitten transverse through the eye, hit the retina, and are translated into neural signals that are carried to the back of the cortex where visual processing happens. And that's true, but it's not as simple as that. In a very real way, what you perceive in the outside world is dependent on the structure and function of your brain itself, as much as, if not more so, than the qualities of the reality that you are perceiving. So I'll give you an example in the form of an illusion. This is called the checkerboard illusion, and you may have seen it before. So I'm going to let you take a look here. So in this illusion, we see a checkerboard, and you'll see those two marked squares, A and B. So for yourself, make the simple judgment which square is lighter and which square is darker. Most people, absolutely everyone who has a normal visual system, perceives pretty quickly that the top square A is darker than the bottom square B. However, this is actually not the case. And I can demonstrate it to you. I can help you to see it if I add this gray bar here that is going to kind of run through both boxes. And then you can sort of look up at box A, look down at box B, and see that tone is actually exactly the same. Now, why does this illusion work? It works because the human brain and the perceptual system, the visual system in particular, is evolved for outdoor light conditions on Earth. If you think about it, vision was very important to our human ancestors, and detecting color in different conditions of light and shadow was crucial for our survival. There was probably one crimson berry that was sweet and tasty and packed with nutrients, and maybe one slightly more maroon berry that would make you barf for a couple days and see visions. And it was very important to know which berry you were eating, even if the berry bush was in the shade or in the sun. So deep in our brain, in some of the earliest regions to evolve, we have some really basic equipment for discounting the effect of shadows. So when we see an object that we perceive to be in a shadow, our brain, without our conscious awareness, automatically makes the assumption that it's a lot lighter than the tone that's appearing to our eyes because of the shadow. And this isn't something that you can consciously control. This is work that deeper, more ancient brain structures that you share with simple animals like lizards is doing for you all the time while your conscious mind is thinking about whatever it wants to think about. So one implication of how deep and unconscious this architecture is that when I take the gray bars away, even I, who put this illusion into the slideshow, still can't convince my mind to perceive these two squares as the same color, even though cognitively I know that they are. That deeper architecture in my brain is running automatically outside of my conscious awareness and changing my very perception. So the way I'm seeing color in this example is more strongly determined by my brain's structure and function than by the actual tone of the colors in the world around me. And that is why I say that your brain creates your reality. Incidentally, the same brain structures that cause us to see the checkerboard illusion were also responsible for the great internet controversy of 2015 that I hope you guys are old enough to remember. The dress that was either black and blue or gold and white. I'm in the gold and white camp. If you're a black and blue dress person, I just really hope that we can, continue to have a harmonious relationship in this course despite our deep ideological differences. So in a very literal way, your brain creates your reality. If it doesn't happen in your brain, it didn't happen to you. And that's a very compelling reason to understand your brain. And this has a lot of implications because we're constantly making judgments about the world around us based on these perceptions that come in part from the architecture of our brain. Why is it that two people can be looking at a man who's holding a cell phone, and one will see that he's holding a cell phone, and another will misperceive that he's holding a gun? There is a brain-based explanation for what is going on in the mind of the individual when they make that misperception. And it's a very important mistake. Understanding the brain can shed a lot of light on all kinds of questions in our everyday lives, from the crucial to the not so profound. So why am I so much more likely to get into an argument with my sweetheart when I am hangry? Why do teenagers make such wild, risky decisions? There are brain-based explanations for both of those phenomena. Why do victims of trauma often have crystal clear, compelling, and hard to shake memories of some aspects of what they went through, but very blurry or missing memories of other elements of the tragic event? There's a brain-based explanation for that. Understanding these phenomenon will help you understand yourself better and understand the people around you, and hopefully lead to a more satisfying life. This brings me to one of the mushier points that I want to make for you today, which is that your brain is where you live. Your mind and the brain that gives rise to it will always be your home. So learning how your brain works is an excellent investment in your long-term health and well-being, because it's always going to be with you. And the more you understand its inner workings, the better you'll understand yourself and be able to live a healthy life full of the things you desire. So I want to close telling you a little story about something kind of cool that happened to me when I was preparing the very first version of this class. I went to a wedding in Joshua Tree. While I was attending the wedding, there's like a typical part of every wedding where you're kind of just waiting around for the bride and groom to do photos or whatever they're doing. They haven't served cake and people are just milling around talking. And, it's a lot of hi, how do you know the bride and groom? What do you do? What do you do? So people were saying, what do you do? And I said, I'm a college professor and I'm developing a new course on the human brain and how it affects our behavior. And the other wedding guests, most of them total strangers, started asking me all of these really insightful and interesting questions about the human brain. It felt like maybe they'd been waiting for a while to find someone to ask these questions to. I was getting, are the brains of men and women really different? Is there something going on in my teenager's brain that can explain the way he's acting? Is there something in the human brain that explains how emotions affect us in particular ways? I loved all of these questions. And I was sitting there thinking, man, I really hope I can get my students to come at me with this level of free thinking and curiosity. Now, the context of the wedding really kind of supported that. First of all, the champagne was flowing and everyone was relaxed. No one was getting a grade. But what I want to do right now is try to recreate that context a little bit. So we haven't started the class. Everyone's new. None of us know anything. And I really want to motivate your curiosity. So as we explore the human brain and nervous system, what do you hope this class will answer? What burning questions do you have about the brain? Could be stuff that relates to your personal life, health, and behavior, or family members. It could also be related to the future job you want to pursue, whether it's working with kids or psychology in another capacity. Just really get creative. And in the reflection questions for this assignment, I'm asking you to just write as many questions as you can. I'd love to get several from each of you that you hope this class will answer. I'm going to have a lot of fun reading them, and I'm going to do my best to build as many of them as I can into our work together this semester. So I hope you came curious.